Hey everyone, I'm John Wood and I'll be showing some machine learning basics and building a model with ML.NET in this crash course. And if you want to see more about what ML.NET can do, please visit my channel in the description. So to start off, let's go over a little bit about what is machine learning. And there's this quote here about Aurélien Géron, and I hope I pronounced that correctly. And he wrote a book from O'Reilly called Hands-On Machine Learning. And if you want to learn more, I highly recommend this book. There's tons of great information in there. And he says machine learning is the science and art of programming computers so they can learn from data. And it's a science because there's a whole process that you kind of follow when doing machine learning, and you produce mathematical models using algorithms. But it's also an art because there's so much you can do for pre-processing the data, for instance, or which algorithm you should use, that it kind of takes some experience and pretty much some trial and error in order to produce a better model. So the first thing is there are different types of machine learning systems. And there are more than these two, but these two are probably the most often that you'll probably see. And the first one is supervised, and that's where in your data set you have a column within your data that you want to predict. So if you're working at a bank, for instance, and you're given a data set of customers and you want to see which of those customers are most likely to default on a loan, you would have a column in your data set called isDefault, and it will tell you which customers have defaulted, and you would use that within your algorithms to produce a prediction. On the other hand, you have unsupervised, and these are where data sets where you don't have that label or answer column for your algorithm to predict, and this is where you want to predict certain patterns within your data. So continuing, there are certain types of each of these algorithms. So within supervised, you have regression algorithms, and these are used to predict values such as house prices or salary. And then you also have classification, which are used to predict classes. Say you want to predict a true or false class. Since there are two of those, that's called binary classification. If you want to predict more than two classes, that would be multi-class classification. And a good example of multi-class classification is doing image classification, where you give your model an image and it tells you what's in that image, whether it's a dog, cat, car, or person. And then unsupervised, you have something called clustering, which is used to predict different groups that have kind of the same patterns. And examples of this are where you want to group out different customers based on their shopping habits, so you can give them different marketing than other groups. Then you have something called anomaly detection, which is basically predicting items that don't really fit the rest of the data. Best example of this is kind of credit card transaction fraud, where it can find out this one purchase doesn't match all the other purchases that you've done in the past, so we're going to flag this as a fraud and then get to you, make sure that it is a fraud or not, or is there something different that you're doing. And now let's go to the machine learning process. And the first part of the process is where you have your data. Now, sometimes you are given your data, or other times you have to actually produce your own data. Either way, you need the data, you need lots of it. And I would also argue that you need a lot of good data as well. You may have heard this old programming adage, garbage in, garbage out. And so if you have bad data, you're not going to have a good model. It may perform well, but it's not going to give good results when you put it out in production and people actually use it. Once you have your data, you would go through data prep or data cleaning. Here you would do things such as removing or updating missing values, or putting categorical or text data into numerical data, since these machine learning algorithms take in numerical data and can't really do anything with text data. Next, you would go through and create your model, and this is mostly where you decide which machine learning algorithm that you want to use. And within each of those categories, like regression or anomaly detection, there can be tons and tons of different algorithms that you can use. Each one of them have pros and cons, and it depends on your data which one works best. So it's kind of a trial and error thing there. And then you will evaluate your model to determine if it performs well on some kind of new data that it hasn't seen before. And if you give it on the data that you use to create the model, then it kind of knows that data already. You want to give it data that it hasn't seen before so it can generalize well to that new data. But oftentimes, you will have to kind of iterate on creating the model and evaluating it. If you get a bad performing model when you evaluate it, maybe trying a different algorithm and then evaluate it again and see how well that performs. And then once you have a decent model and you can deploy it, and then once that goes out into production systems for people to use. But then you would often have to go back and do this process again because your data could have changed completely, and which just totally invalidates your model and degrades the performance of your model. So you have to go back to the data and do this process all over again. Alright, so now let's focus on what ML.NET is. And to put it simply, it is machine learning for .NET developers. And notice I said .NET developers instead of C# developers, even though we are going to be using C# for this. But you can also use F# for this as well. And a couple of benefits of using ML.NET versus some of the more popular frameworks in Python is first is we kind of alluded to it earlier, but it is built for .NET developers. ML.NET itself is built in C#, and it is just another NuGet package that you can download and use within Visual Studio. And another thing is its performance. And we have a couple graphs here from the ML.NET website. And there's two different performance measures here. First is the accuracy, and it's using an area under the curve accuracy, which is performance metric for classification algorithms. And we see here ML.NET actually performs better on the same dataset and the same pipeline than the Python frameworks of scikit-learn and H2O. And then the other metric here is the kind of the training and testing time that it took. And ML.NET took a lot less time to train and test data than the scikit-learn or H2O frameworks did. And I would also say that deployment is also a benefit. Pretty often you will see these machine learning tutorials and they'll show you how to create models, which is great, but then once you create a model, what do you do with it now? And it's not any useful if it's not deployed to where other people can use it. And TensorFlow probably got popular for a reason because it actually came with something called TensorFlow Server, which helps you deploy your TensorFlow models. But ML.NET also comes with ways where you can easily deploy your models to use within web applications or desktop applications. And ML.NET actually comes with a UI tool that you can use, so you don't have to do a lot of coding to generate your ML.NET models. And this is actually built into the newer versions of Visual Studio, and it's called Model Builder. And it is just kind of a wizard-like UI where you can give it your data and it'll do the training for you. And behind the scenes, it's using something called AutoML, which stands for Automated Machine Learning. And that just takes your data and it goes through all the different algorithms and measures the metrics on those algorithms to give you the best performing model. And with that, let's build some ML.NET models. Before we get code in here, let's take a look at the dataset that we're going to be using. And I'm here in Kaggle, which, if you're not familiar with Kaggle, is kind of a social network for data scientists and machine learning engineers. Also a place where people can upload some data for people to use to practice their machine learning skills. And the dataset we're going to be using is the California housing prices here. And it's actually used in that hands-on machine learning book that I mentioned earlier. Let's take a quick look at the data here. So I have a few columns, the longitude, latitude, total rooms, total bedrooms, population of the area, and some other features of the houses within a particular area. But what we want to do with this data is predict this median house value. Since we have our item within the dataset here, we know that it's supervised, and we're predicting a monetary value of the house. That tells us that it's a regression algorithm that we need to use. Alright, so I'm here in Visual Studio 2019. I have a console project loaded here. And first thing, let's add in our data. We downloaded that data from Kaggle, and it gives us a CSV. So I just drag and drop that in to my Solution Explorer. And I'm going to look at the properties, and I'm going to tell it to copy to the output if it's newer. And this allows me to use that data set without having to go to a bunch of different paths to get to it. And so like I mentioned before, ML.NET is a NuGet package. So I just right click and manage NuGet packages. And it is called Microsoft.ml. Here we go. And we're using version 1.5.1 here. And now the first thing we need to do for ML.NET is we need to create something called the ML context. And we do that by creating a new instance of the ML context. And this ML context allows us to do pretty much everything we need to do with ML.NET. For instance, we need to load in our data. And to do that, we do context.data.load from text file. And this is a generic method, so we need to give it a type to load to. and I'm going to call this housing data, and I'll create that in a minute. But first, let's finish out this method here. The first parameter takes in the path of where the data is, so I'll just call housing.csv. Next, there are a couple of optional parameters, such as if it has a header or not, and we can double check here it has the headers in the file, so we can say true. Then next we can tell it what the separator character is, and we can look at that at the raw data for that, and we can see that they are comma separated, so we just put a comma in here. Now this housing data, we'll generate a new file for that, and this is just a new class, and this is how we define our input schema for that data. So we just need to put in properties that match this data schema into a C# class, and I'm just going to paste these in here. These are all properties. I also added some attributes to these properties, and these load columns tell ML.NET how to load in that data. The numbers within the load column parameters are basically the column numbers, which are 0 based, and those are what columns these properties need to match up to. And we also have remember the median house value is the column that we want to predict, and so we also give that a column name of label, and this is telling ML.NET that this is our label column, but we are calling it the median house value. We have our data loaded. Next, I'm actually going to split our data using context data that train test split and pass in our main data, and I'm going to give it a test fraction of 20%. So this is going to split our data into two different data sets, a train set and a test set, and it's going to take 20% of our data into our test data. And why do we need to split? Well, when we create our machine learning models, we use the train data set, and that's the data that's going to be used to train on. But remember, we also evaluate our models, and we want to evaluate on data that our model hasn't seen before, which would be everything in the train data set. So we give it our test data set to give us a more accurate picture of how well our model does. So now that we have our split data, I'm going to create some features. Now, features are the columns that we give our machine learning algorithm to use to make the model. To do this, I'm going to use our split data, our train set, and I'm going to get the schema from that, and I'm going to use some link methods here. First is going to use the select method, which is similar to a JavaScript map method, and I'm going to take the name of our column here, of our schema, and I'm going to use the where method to filter out different columns. So the column name, I don't want the label name, which remember in our schema here, that's just what we called our median house value. Then I also don't want to use the ocean proximity column. The reason for that is ocean proximity is a string. Our features that we want to use right now are all numerical, are all floats. So we're getting all of our numerical features here. And then I want to set those to an array. Next, let's create our pipeline. And this is going to be everything that we need to do to create our model, including our pre-processing steps and our choosing of our machine learning algorithm. First, we do some pre-processing. We use that context, and we have some transforms that we can use. And remember that ocean proximity is a text column or a string column. So I'm going to use the text.featureizeText method. It does a few things such as normalizing the text and then creating numerical values for the words in the text. So the first parameter is kind of the output column that we want to create from this, and I'll just call it text. And then it takes in the input column name, which is going to be the ocean proximity. And I can append as many other transforms as I want to within this pipeline. The next one, I'm going to use another transform, and I'm going to concatenate into a features column. And remember all of these features up here, I'm going to concatenate all of those together into a single column called features. And I'm going to append another concatenation where I pass in the features from this previous concatenation. I pass that in, and I also want to pass in the text column from this featureized text, and that's going to go into a new column called features. And then next I'm going to append our machine learning algorithm that we want to use. So we use the context, regression, and then the trainers, also called algorithms. And I'll use this Poisson regression. And you don't really need to know the nuances of the algorithms to build machine learning models with ML.NET here. Alright, so we have our pipeline, and now we can create our model using the pipeline.fit method. And we pass in our split train set. And once that runs, we have our model. And what we can do next is that we can create some predictions using the model.transform, and we can pass in our split test set. So what it's going to do is our pipeline fit is going to train the model based on our train set, but the model.transform is actually going to use the model on our test set to make predictions. And we can get some metrics from it here using context.regression.evaluate method to evaluate our model. We pass in our predictions, and because our label column name and our score column name, which ML.NET does behind the scenes, pass in the predictions since the other parameters are using the defaults. And now we can look at our metrics. So we do console, right line. Depending on the algorithm that we choose, there are different metrics. For regression, R squared is one that is used pretty often. And we do metrics R squared. And now let's run this and make sure nothing fails and we get a decent R squared. There you go. So we have an R squared of, it's like 54%, and that's not real good, and you want to get closer to 1 in your R squared. What we could do is we can change our different algorithms and see how that works, or we can do some additional pre-processing on our data to help give us some better algorithms. And this is where that art of creating machine learning algorithms comes into play. But instead of doing all that, I'm going to show that model builder that I mentioned earlier in the slides. And to do that, in Visual Studio 19, it actually comes with it. And to enable it, you go to the options. In the environment section, go to preview features. And near the bottom, you want to click enable the ML.NET model builder. And from there, in any .NET project, you right click, add, and you have this machine learning option here. Now if you don't see this, after checking that enable and restarting Visual Studio, you can go to extensions and manage extensions. Make sure the ML.NET model builder is installed. If it's not, you can search for it and install it from there. So let's add machine learning here. And the model builder lets us do quite a few different scenarios here. We can do classification items and value prediction, which is what we're going to be using for our regression data. You also have image classification. Note here that you can use all these locally, but for image classification, because images have so much data in them, you kind of need a GPU to train this model a lot faster than you can do on your CPU. So you can have the option to use Azure Machine Learning Service, where you can use that GPU. And then recommendation algorithms as well. And there's some limited ones like clustering and anomaly detection that we mentioned earlier. So we're going to use value prediction. I'm going to train locally, and I'm going to use that same file that we did for our housing data. So there's our data there. And we tell it what column that we want to predict, and that was that median house value. You can remove some columns if you want to, if you already know that's not going to be helpful for the machine learning algorithm, such as like ID columns if you're getting from a database. Next we'll select train, and here we select the number of seconds that we want it to train, and this kind of depends on your data, but for here I'll just do 15 seconds here, and we click start training. And you see the output here, that's going through all sorts of different algorithms, and we got the R squared metric that it's getting. And so that finished, and it says top 5 models explored, and the top model is this fast tree regression, and we see we have R squared of about 86%, and that's a lot better than that 54% that we got when we built this model by hand. Next, we can evaluate this, and this gives us the opportunity to put in our own data here and select predict, and it gives us a prediction. And then last, it generates the code for us. So we can click code and add projects to our solution here. You see it added our two different projects here, and we have this mo-model.zip, and this is that saved model from, and also shows us how we can consume it here. Alright, so I think I'll end things there. I hope that gave y'all some good basics of machine learning, as well as how to build machine learning algorithms in C# with mo.net. And once again, if you want to see more mo.net, please check out my channel down below in the description. And thanks to Traversing Media for giving me the opportunity to do this guest video. Thanks everyone.